I'm going to talk today here about running Flink everywhere. It's a pretty broad title. More concretely, it is about running Flink in basically in various setups. Running Flink standalone in Yarn with Docker, with Mesos, with the next big thing that Elon Musk comes up and all these things. Okay, so let's get started there. So when I was actually preparing for this, I thought, okay, let's actually have a look at how are the users currently running Flink, and I thought, okay, it's probably going to give us two results: standalone and Yarn. And I kind of just searched through the mailing list for keywords like deploy and so on, and it turned out that that users are actually fairly creative today already in ways to deploy Flink. So just searching for 2 minutes on the mailing list, you can actually see that there's a bunch of people using apparently standalone classes in production. The vast majority does go into Yarn jobs, a few Yarn sessions. Some people are actually using Flink in standalone mode in cloud settings, like preparing an Amazon AMI image or so. Some users are actually using Flink on Mesos, just Dockerizing Flink processes, starting the Docker containers on Mesos. Some users are using Flink on Mesos via this adapter framework called Myriad, which makes Mesos look like Yarn. So you can use Flink's Yarn functionality to run Flink on Mesos. I've actually seen users who use Flink together with Docker and Kubernetes, and I don't get the details of this thing here, but OSGI is kind of a specification to build composable Java services and to dynamically load modules and plugins, and apparently some people are doing that. So kind of dynamically load Flink task managers as modules of other applications and so on, and run their code there. So it's a pretty diverse space. And it's getting even more, right? If you're looking at the roadmap, the pull request, there's Flink on Mesos directly coming up. In two ways, actually, running individual jobs on Mesos and running jobs on Mesos as sessions. A session here, by the way, just to help you understand what I mean with this, a session is you actually start a Flink cluster, and then you have the resources there running, and then you run a series of short-lived jobs against the same resources. It has the benefit that compared to just running all these jobs individually one after another, you don't really relinquish the resources and get them back in between, which is, I think, a little faster in the case of Mesos, but especially in Yarn, the phase where you acquire the resources can take quite a bit of time. So actually having a session and issuing multiple fast jobs against that can save you a lot of time compared to just running multiple jobs after one another. So it's actually not that everybody uses a different technology, but all in the exact same way. So yeah, one dimension in which all these technologies are kind of different is, what is the prime mode of running job? Do you run one job at a time, or do you basically start a cluster, like I said before, and then run multiple jobs? And I tried to sort of highlight what's the preferred way to use in the individual setups. For some, I couldn't quite determine it. This one I'm unsure. This one I'm a little unsure. I think it's isolated jobs, but I couldn't quite figure it out from the mailing list. So this is so you can actually see that there's two very different ways that people use Flink here already: individual jobs versus sessions. Now that is maybe more of a subtle difference for many users. Let's actually look at something else that is pretty important to deal with. Who is actually responsible for managing the resources in what setup? So are the resources controlled by the framework or by another service? So what do I mean with that? Let's assume a machine goes down, hard failure, and you need a backup machine at some point in time. Who's responsible actually for providing that backup machine? Will Flink and the framework that it integrates do that? I guess in the case of Yarn, Mesos, and so on, and running Yarn on Mesos is actually Will, right? So Flink is responsible for saying, okay, I'm actually missing some resources, give me new resources. In other cases, it actually won't. So the way that, for example, let's say Docker and Kubernetes works is you have a bunch of containers running, and if a container disappears, first of all, the container goes down, right? It's just a way. And Flink doesn't really know anything about how the container is started or so. So it cannot really acquire a new resource, and it's relying on some service like Kubernetes to watch the containers and say, okay, here's a container that went down, bring up a replacement container. So it's sort of managed outside the framework. It's managed by another service, in this case the Kubernetes service. And the resource management here, who deals with a failure of a container or a process, is almost the same question in the end as who actually deals with resource elasticity. It boils down to almost the same thing. So if you've heard the talk by Till about Flink adjusting to dynamic workloads, acquiring new containers if the load goes up, releasing containers. Whose responsibility is it actually to make this decision? Is it the responsibility of Flink, or is it the responsibility of someone else? And it's actually the same thing. Here in these green lines, it's kind of the responsibility of Flink to decide, okay, this should have more resources. And in the case of the blue squared, the blue marked fields, it's in this case the responsibility of Kubernetes to just say, okay, I'm seeing my containers all run 80% CPU, I should probably add 2 more. Or in the case of the cloud, think of it as an Amazon EC2, what's it called, like elastic scaling group or so, where you monitor the instances and say, I should probably fire up 2 more because I'm hitting a certain level in CPU load. So the point that I want to make is that the paradigm between these different resource frameworks is different quite from the perspective of the user and also from the perspective of Flink. And there are a bunch of more dimensions actually that are coming up in how do you deal with these resource managers that we really like to take into account. I mentioned the first one, dealing with dynamic resources, number of task managers effectively changing over time. The other question is uniform versus heterogeneous resources. There's quite a good potential to actually improve resource utilization by saying, don't put everything into a container of equal size. Flink has this notion of packing certain operators together into a slot to kind of not have the exact same container size for an individual mapper that doesn't do a lot, and for a very heavy window operator, where it kind of says, okay, let everything share the slots and sort of like balance out the resources and rather solve it through parallelism. But it's a very valid model to also say, I really want to have fine-grained isolation between each operator, and in that case, you would really want the mapper to run in a smaller container than the big window operator. Otherwise, it would just be over-provisioning or under-provisioning for one of those. That is naturally also something that doesn't fit with every framework, right? Some of them can acquire dynamic resources or can specify the size of containers that they want, and others cannot. Another dimension that's coming up is how do you actually guarantee trusted processes? There's a talk tomorrow about security enhancements, and you'll actually see that one of the most important dimensions is trying to determine whether a process is trusted from a user perspective. Is a trusted process or not? Can it have user credentials, secrets, tokens, passwords, and so on, or can't it have? The ones that have credentials cannot run any other user's code because you might introduce possibility to leak that. Again, another dimension to come up, solved differently in different resource managers. Which processes share user code and which don't? So. What is the point of actually discussing this? The point is that trying to integrate Flink with resource frameworks has started to become a tough thing. I mean, we have Yarn and Standalone, and we started expanding into Mesos with contribution from Aaron and EMC that he's going to be talking tomorrow. And we've been looking at getting the feedback from the users that use Kubernetes and ones that say, hey, I want to install it and then use the Amazon autoscaling policies and so on. And at some point we arrived at the point where we said, okay, this seems to be hard. There's not one abstraction that fits all these things. It just doesn't. They're too different. The requirements, the paradigms behind the resource managers. So what are we doing there? It's actually a bigger initiative that we started on, reworking the Flink process model to make it more flexible, more composable, to actually fit those various requirements. And it's kind of hidden under the umbrella of this beautiful name, Flink Improvement Proposal 6. It's not a very speaking name, but yeah. It's actually, it's one of those things, we started adding them a while back called Flink Improvement Proposals, FLIPS. It's a collection of major issues that we're addressing. This is number 6. It's actually a pretty big design document that's going into many details. So anybody interested in like a lot more details, feel free to also look there. The core idea of this is to to actually go and say, all the parts that we're using to interact with certain services, we actually need to break this down in more fine-grained building blocks that we can sort of flexibly compose then to make this meet different kind of requirements. And yeah, and this is what it's all about, and this is what I'm going to talk about today about how do these building blocks look and how do we actually compose them? What does actually Flink look in a Docker Kubernetes setting? What does it look like in a Mesos setup? As I said, it's a pretty big effort. It's been going on for a bunch of weeks now. It's pretty active. It's currently being driven mainly by Alibaba and data artisans. And yeah, let's just go into it, and I think you'll get how what it's going to be about. Let's do a quick recap in order to understand this building block model, and look at how are things working today. So, simplest thing you can have a Flink standalone cluster, job manager, task managers, and a client that submits a job. When you start the standalone cluster, you're firing up a job manager, a task manager, and the first thing that's happening is the task managers try to discover the job manager in some way, in HA via Zookeeper, and in a non-HA way, just through configurations or discovery services. And then you have the job manager and the task manager. They found each other. The client submits a job to the job manager, and the job manager starts sending work to the task managers to execute that. How does it currently look if Flink runs on Yarn? It's a bit of a more tricky picture. It has a lot more steps. So if you're actually submitting a single job to Flink on Yarn, what is actually going to happen is that this client first contacts the Yarn resource manager and say, hey, bring me up a Flink application. And what it does, it actually submits not the job, it submits Flink as an application as a whole. And the Yarn resource manager brings up an application master, which then asks for a certain number of task managers. At the same time, the client starts polling the status here, so to understand how many resources are actually there. And once all the task managers are up and have registered, the client is going to figure that out. And at that point in time, say, OK, now the Flink cluster is ready, and now I'm going to submit the job. And then the job manager keeps deploying the tasks. And while this looks a little bit like there are a few things that shouldn't be there, I agree, especially this polling thing here is not very nice. And so why does it actually look like that right now? And the reason is that this is actually a standalone mode in disguise if you look at it very closely. So there's task managers that have been started by someone, the job manager has been started by someone, they register it, then the client submits, and then it deploys. So if you take out steps basically until 7 and leave the polling out of the picture, then it's standalone mode on Yarn. We just use Yarn currently to bootstrap a standalone Flink cluster. And that's why also Flink on Yarn currently behaves as static as it is. It doesn't behave as dynamic as Yarn would allow it to be. That's definitely something that needs to change. So what you can see is there's basically a few components that always occur back. It's the client, the job manager, and the task manager. So I'm leaving the client out of the picture right now, but in this reworked world, we're actually decomposing it into more components that Flink will actually have as first-class citizens. A resource manager, the job manager, a dispatcher, and a task manager. The task manager is largely the same. It's responsible for executing tasks. It basically contains the heavy state and everything else. And if you wish, the job manager mostly decomposes into these 3 components. The job manager by itself is going to be a strictly single job component. That's not really involved with receiving a job and figuring out managing across job boundaries. It's not responsible at all for thinking even in terms of availability of instances and task managers. It just thinks by itself in the availability of what we call slots. A slot is a unit of resource that you have that you own and that you can deploy a task to. Where these slots come from, they usually come from task managers, but how they arrive there is not of the concern of the job manager. That is actually the concern of the resource manager. The resource manager is the component that is kind of tailored towards certain cluster frameworks, or at least it's the one that's integrating with the different cluster framework APIs. So the resource manager is the one that calls the Yarn APIs, calls the Mesos APIs, and so on. It may live across jobs or for a job, and the resource manager actually thinks in terms of task managers, in terms of containers. So resource manager thinks in terms of containers, job manager just thinks in terms of task slots, which may come from same or different containers. And the dispatcher is the component that is actually responsible for all the across-job logic, if you wish. Yeah, and like the basic pattern of interaction between, let's say, at least the job manager, resource manager, and task manager is that the job manager asks the resource manager for slots for the resources to execute tasks in. The resource manager will start task managers if needed, if it can and if needed. Once the task managers actually announce the availability at the resource manager, this job manager can start deploying tasks there. This is a highly simplified version. Like the proper protocol looks a little more complicated to make sure that, in the presence of various failures, you can always run a reconciliation and everybody syncs up with everybody else. So the exact protocol has a few more steps, but those are I guess, the basic ones that I think are interesting to understand. So let's actually look at how does Flink on Yarn work if we rebuild it with this model. So it looks a lot simpler, actually. So we have a client here that simply says, okay, I'm submitting the entire Flink plus job graph plus jar to the resource manager. And so it's basically just one thing that contains everything submitted to the resource manager. And the resource manager starts the application master containing a Flink Yarn resource manager and a job manager for that particular job graph. Just as background for those who are a little newer to Flink, a job graph is kind of the once you've run your user program, it is described as a job graph, as the computational graph that should be executed in parallel. So, and as I said before, the job manager is strictly tailored towards executing one job. So it actually brings up this job manager for that job, the Yarn resource manager. As the job manager needs more resources to execute that job, it asks for more resources from the resource manager, which brings up new task managers. They come back and tasks get deployed. It's not just an internal change that this is like a code cleanup from our side. There's going to be a few differences that you can also notice as a user, some more obvious, some less obvious. One thing that I know everybody that has debugged, let's say, class not found exceptions and so on before may actually appreciate is that in this model, all containers are always started, for example, with jar files, config files in place, and so on. So it's a very robust model when it comes to class loading. It doesn't have to do all the dynamic class loading that we have in Flink otherwise. It's a very secure model in terms of credentials and secrets are strictly bound to one single instance of a job. Which is much easier to provide a hard guarantee on in this model than in the one before, where you sort of bootstrapped a standalone cluster in Flink. Slots are allocated and released as needed or not needed anymore, which is basically the most important thing to say. Resource utilization of a job changes over time. It's kind of the enabler to say all the work that the autoscaling is doing for resharding state is actually making a difference in using Yarn. And something that if you actually run it, and play around with it, may notice immediately is that once you actually submit a job to Yarn, the client is done and can shut down. It's not, you don't have this command line open there for 2 minutes waiting and giving you updates on how resources are coming up, and then the job is finally being submitted. So it's basically a one-shot operation. One other thing that this model enables may not be obvious immediately why this is interesting, but it enables you to actually factor out the job manager and the resource manager, which has some interesting properties in really high availability settings. For example, Yarn allows you to have only one instance of the application master, but if you want like really very high availability in terms of on the failure of a job manager, some other job manager should immediately take over, and it shouldn't have to wait for Yarn to discover this and start a new resource manager. You can actually have multiple job managers that can take over for each other, and you may have only one resource manager, and it will mean that until this thing is up, there's not going to be any elasticity, no additional resources, no resource release. But at least with everything that's currently there, you can keep going, which is, I think, very interesting. And here's a slight evolution of this, taking dispatcher into account. The dispatcher as being the single point of entry to to a Flink cluster on Yarn with multiple jobs. So the jobs still run all individually with an individual application master, individual task managers, so proper process isolation against each other. But they have a common entry point. So they have one point that kind of knows about all jobs that are in the cluster. And this is also a natural point for running I'd say a web front end that lives across the job or that knows about multiple jobs. And if you actually see this, then the step from there to Flink on Mesos is actually surprisingly straightforward. You actually have a Mesos dispatcher here and a Flink Mesos resource manager. Otherwise, it looks pretty much the same. Now, this is a mean simplification. It's not just a Mesos dispatcher and a Mesos resource manager. There's a lot involved in going to a Mesos resource manager from a Yarn resource manager, and you can learn a lot about it tomorrow in the talks from Aaron, who's going to go into all the details. How do these things work? How do they handle failures or reconciliation and everything? How does Flink in standalone mode work, actually? And there you can actually see another very interesting use of how the dispatcher works, because the dispatcher is in standalone mode actually the kind of the replacement for the living service that exists jobs. So in standalone mode, what you actually bring up is a Flink master process, or if you're in HA, multiple Flink master processes which do leader election among each other. Each one running a standalone resource manager which cannot acquire new resources, but just accept what it discovers. And the dispatcher actually accepts job submissions and spawns internally new job managers for that. So actually, this is another way of using the dispatcher. And you can actually see that this is one step away from saying, let's not spawn the job manager in process. Let's actually spawn the job manager out of process and even have something like dividing up the task managers between different jobs. So things you can do there is even go in standalone processes to like more strict isolation between the processes belonging to individual jobs. And some people have even suggested when they saw this design, why don't you actually run just a small daemon that spawns a task manager on a machine? And this is kind of like a mini Yarn mode almost in standalone. So it kind of gives you the building blocks to make the steps towards something like that very easily. One way that works completely different, but also very nice in this model is if you actually run it on Docker and Kubernetes. And one of the most common complaints I've heard about when people use Flink right now with things like Docker and Kubernetes is that it doesn't fit the paradigm really well. Because what you do in this case is you Dockerize a streaming job usually. And that doesn't work so well with Flink because it has this baked-in idea that a client submits the job in the current model, right? So what a lot of people have to do when they run this Docker on Kubernetes thing, that can kind of only use it to bootstrap a standalone cluster. Then they have to go to some other point to submit a job, which can then shut down. Or they kind of try to squeeze the job submit and the job manager all into one container, but then they again have to worry about at what point can I do the job submission, when is the cluster ready, and so on. So this is kind of a tedious thing. You can work around it, but it feels a bit hacky. It kind of fits this. You can kind of model it much nicer in this new thing. So let's just assume you've Dockerized the task manager, and then you've Dockerized your job with a template of a program runner, which is just going to execute your program and then spawn a job manager and a container resource manager in the same process. And that is basically it. So the container resource manager is, in some sense, kind of similar to the standalone resource manager in that it cannot try to acquire new resources. It can just say, hey, whatever comes my way, I'm going to shove to the job manager. So whenever a resource comes up and I discover it, I'm just going to tell the job manager, hey, it's here, please use it. So this is actually, I think, kind of an interesting model because it's almost a blueprint model for how I think it works kind of nicely to use Flink in all setups where Flink by itself doesn't control resource acquisition. So it just says, yeah, as resources come up and announce themselves my way, I'm going to start using them. So Docker Kubernetes is one way to use this, but actually running it on EC2 with auto-scaling groups or so, I think would just work exactly the same way. There's even a very nice evolution of that, where you could say you actually have a single container image for the job. You start n of those, and in a high availability setup, Flink's going to do leader election for the master anyways. So why not do the following thing? The leader becomes master and all the others become workers, and then, if one goes down, another one's going to take up the role of a leader. So you actually get around the fact that you have to Dockerize, that you have different types of Docker containers, one generic for workers and one that is special for a job. You could even go to such a point. I think this would all fit quite well. To actually get the proper benefit out of this integration, this kind of relies on the work that Till's talk described, how Flink adjusts to changing workloads, how it can redistribute state with key groups. Because what you can really do in the end is exactly that. You can go to the point that you say let's say the Kubernetes service is responsible for actually monitoring utilization, and it has a component where you can define rules and say, I want actually additional Docker containers to be started if certain utilization levels are crossed. And once you actually do this, and these containers come up, and they end up, the Flink container resource manager ends up discovering them. It's just going to shove the resources to the job manager. And the job manager doesn't really have to implement any sophisticated auto-scaling policy. The only thing that it does is, cool, 2 new slots, cool, let me scale out. Or some slots disappear, let me scale in. So this kind of a very natural model to say, you're not really confining Flink to work with a resource manager that's deeply integrated with. You're just saying, manage your resources outside, and then, Flink reacts to whatever happens. All right, we have a few more minutes. One thing that I'd like to mention here is multi-job sessions, because all of what I've been talking about before was kind of the view of a single job. Right now, you can actually run against the yarn session or the standalone mode a lot of short-lived jobs, and there's some value in doing this, right? I mean, in the streaming API, it seems like people really like the idea of it's just one job, you deploy it, it's one unit that keeps running. But in batch, you often have a lot of jobs kind of that built on top of each other. So one batch execution for the first part, then there's another one for the next part, and so on. And you really don't want these to be completely isolated against each other. I mean, for one, it's just very wasteful to release and reacquire the resources, and for another, if we ever want to start doing something like caching resources in a process to carry over to the next step, and this certainly doesn't work very well if you actually release the resources in between. So how do you actually do multi-job sessions? So multi-job sessions, I hinted at it before, are kind of handled via the dispatcher. So this looks again a little similar to a standalone mode bootstrapped on Yarn, and I mean for good reason, because any multi-job thing looks a little bit like a standalone, a standalone mode in terms of you have longer running task managers, and you have a job manager that accepts multiple jobs. So the only difference is the job manager here being still a separate component per job, the dispatcher being actually the component that accepts multiple job submissions. It can deploy the job manager inside the process. You can actually go to the point that you say, yeah, it should be multi-job, but it can still be single user. So one user can deploy one job after another, just reuse the instances, or you can say this should be able to handle multiple users. It's not going to be one overloaded design that tries to do anything, but you could just say, I have a single user dispatcher, or I have a multi-user dispatcher. I actually start my job managers in process or out of process on Yarn or so. So it kind of gives you the ability to model these things kind of flexibly. Yeah. I've actually said most of these things. I guess the main difference between sessions and jobs being, sessions are longer running, but from a privacy and security perspective, you got to be aware that all jobs of a single session will eventually run with the same credentials. You cannot really say you switch credentials between jobs in a single session, because parts of it is just you couldn't make this safe. As soon as some user code has run inside a process, you have to assume that this process is compromised on behalf of that user. You can never guarantee that it wasn't some malicious code that hacked the JVM that they injected there. So nobody else should, after that, send its credentials in there. And the other reason is just the way that all the Java libraries work for storing authentication information. It's just there's one registry per process. Sorry. All right. with that, I am basically through. There's quite a bit of other dimensions that I didn't really go into detail, but that I quickly want to highlight at least. I said initially dynamic release of containers and containers of different size are dimensions that we're concerned about. The dynamic acquiring and releasing of resources is almost like happening automatically in this model, right? By virtue of not saying we're starting the task managers by the application master and giving them to the job manager before we're even thinking about a job, but they're started as the job manager starts to allocate slots. This kind of comes automatically, which is a very nice side effect. Resource profiles are the means of kind of using containers of different size in the system. So this is a bit of a it's a bit of in flux there. The design isn't completely finalized. The Alibaba Blink prototype actually implemented something like this, and they kind of motivated that we do something similar here. For things like Yarn and Mesos, it works pretty trivial. It's just something that you attach to the request where you say, I want the container to be at this size, exact or at least. And then in some sense, the trickiest thing is how do you actually expose this to the user in a nice way? And there are a bunch of ideas floating around. You could just have an annotation on a function, like on a map function, a window function, and say, hey, this should run on at least so many resources, or some other way of passing a profile that you attach to a function. But both of these things work well in this model. So the basic idea of what I've talked about here is there's a zoo of these resource management frameworks, and there's not just a bunch of competing frameworks. They're also following very different paradigms. So the first approach to say let's come up with one abstraction that covers all just ended up in trying to build one giant abstraction that failed in the end. So the second approach that we took is actually decomposing what we currently have into building blocks and just reassembling them differently in different settings. So there's actually in the end a dedicated Flink on Mesos runner, Flink on Yarn runner, Flink on, let's say, Kubernetes style runner or so on, which are all in themselves very, very small because most of them just parameterize a few resource managers and job managers how they compose them together to actually cover the pattern. I think that's it. That's the main takeaway. Thanks. We finished surprisingly early, so there's time for a bunch of questions, I think.
So I think, correct me if I'm wrong, but currently the cross-job scheduling in the job manager is very simple, right? Just next slot available. So
yeah.
Has that changed when you moved it to the resource manager, or this is for standalone mode?
Okay, that's a very good point. So actually multi-tenancy in Flink is, if you wish, very rudimentary, right? We've sort of told everybody if you want something like you have requirements for proper resource management, priority scheduling, and so on, just run them as individual jobs and on top of something like Yarn, which actually has these scheduling mechanisms in place. So the job manager is actually in this model here not concerned of that with that anymore because it's just it doesn't even have the multi-job, multi-user functionality anymore. The dispatcher, I would assume that in the first version we're probably not going to build that in. I still think that this is something that you should, I guess, delegate to Yarn, Mesos, or Kubernetes. If you don't, then again you have this code in place in multiple parts, right? You have some policies about balancing in the different queues you have in Yarn or in the scaling policies in Kubernetes, and then you would have some other rules in place inside Flink. And I don't think they should be in two places. I think they should really go into one thing there. It would mean that the standalone mode doesn't have proper, priority scheduling.
Right.
My guess this is a limitation that's going to stay there for a bit at least. And
Okay. Thanks.
Yeah, it would be my take. I mean, it's an open community. If somebody says like, hey, I really want to run this in standalone mode, and sure, I'm going to contribute a fair schedule, then of course be my guest. But I can only speak like for, I don't see myself working on this anytime soon. It seems to be okay for most people to say, yeah, it's solved by Yarn or by Mesos or so. feel free to contradict. But yeah.
Hi. Do you see some potential for jobs running in a session to share information, maybe the output from one being used by the next or something? Or are they independent?
Yeah. There's absolutely some value in having a session for exactly that, yeah. If jobs build on each other in terms of, so right now actually if you run a Flink job that consists of multiple parts, you have some part of the job and then there's something that forces it to execute. Let's say you want to collect results back to the client or you want to get a count or so. Then this forces execution and this will make a job. And then if some part continues afterwards, it's not going to really build on the one before, but it's going to be a new job that may be consisting of the part before and the new part. So there's no caching logic in there right now. It doesn't mean that there's no fundamental reason for it to not be in there. It's just nobody built it in there so far. If anybody ever wanted to build it in there, this would be one big reason to actually use that model exactly. Because that at least keeps the process of the process in which the job manager runs alive, which means you can actually carry forward the execution graph between one job manager and the other, which would be the point that records all the information about your intermediate results that are cached you may want to hold on to.
Yes, my thought is that, is it part of the semantics of a session that those intermediate results are still available? Is that something that we want as part of the semantics?
I think that's a good question. It's it kind of, yeah, it's a very good question. It depends on if you really view the session as a one job thing, it's just a multi-part job, or if you view the session as just a bunch of pre-warmed resources and completely independent jobs. In the first case, I guess you want to carry over intermediate results. In the second case, I guess not. Question is if you need two special cases for that. My gut feeling would be actually you don't. Whether something is a multi-part job or independent jobs could just be completely, Flink could be completely oblivious to that.
Okay, catch it. He didn't hit you? No. You're okay. So if I'm in development cycle and I want to iterate quickly, run my job, then change a little bit, run it again, would that be a use case for using sessions? Or can you only change the job graph but not the jars?
No, that's actually a very good point. The session mode will, if you look at it here, can I get an arrow? Or maybe pointer even better. So the main difference again here between the yarn session and the yarn job is if you look at the first submit call, right? What does it really submit? In the Flink per yarn job, this thing submits actually Flink plus the job. So that has all the jar files. For the session, you can really, again, in the first call, what do you submit to yarn is only Flink. And then you submit the job, which means the job graph and the jars individually. So this thing is, there's no other way than for it to do dynamic class loading again, which is, the good news is, the job graphs can change. You can just submit different jobs and they can be completely different, have completely different dependencies, libraries, and so on in a session. There should not really be a downside if the dynamic class loading works well. I think it's working surprisingly well if you're just using like Flink code. There's always if you use third-party libraries which internally do dynamic class loading, they not always do it exactly in such a way that it's compatible with Flink. So certain external libraries that you use that are, that have issues with dynamic class loading are sometimes vulnerable to not work super well in the setting. They work much better in the, per job isolation, all dependencies in the class path. I think that's the main difference.
Hi, Stephan.
Hey,
so the dispatcher, you had a REST API in it, I think, but I think I saw somewhere that the client would still be a Flink client. So is it going to be a REST client or a Flink client?
There's a good point. I think it's to be specified. My feeling is that everything that talks to dispatcher should be REST.
Yeah, we had issues before. We bundle our Flink client in our application, and it explodes, and then we get conflicts with things like Netty and stuff like that. So it's very nice if you have a REST client.
Yeah. So my gut feeling is that everything that talks to a dispatcher should be REST. So these calls here could be REST. This obviously can't because I think the calls to the yarn resource manager are not REST underneath the hood. No. So if you go to let's say this here, right? This can be a REST call going to the Flink yarn dispatcher, whereas again, this thing here is not a REST call. So it kind of depends. Yeah. Like whenever you talk to a dispatcher, you do the REST call, and the dispatcher does the whatever proprietary RPC.
Yeah, if it's going to be a long-lived service, like, is there any chance of rolling in a history server or something at some stage? I don't know.
Yeah, I think this is the natural part for the history server to go. Yeah, everybody's been asking about that. Now we just need a volunteer to do it.
Thanks.
Thanks a lot, Steph.
All right.
Thank you.